In this study, the finite element method is applied to investigate the mechanical behavior of aluminium notch structures reinforced by composite patch. The influence of the geometrical and mechanical properties of the patch and the adhesive is analyzed in this paper. The presence of the patch contributes to the stress reduction at the notch tip, especially in the case of a double patch reinforcement. This reduction is seen because of a transfer of stresses through the adhesive towards the patch. It can be observed that the increase of the patch thickness leads to a decrease of the maximum stresses at the notch tips. This behavior is noted for all reinforcement techniques. The increase of the patch thickness decreases the stress concentration factor at the notch tip. In addition, the double patch presents more reduction of the stress concentration factor than the simple patch, especially when the patch thickness becomes higher. The values of the stress concentration factor are strongly affected by the patch type, so we can say that the boron epoxy patch allows a better absorption of the stress transmitted by the notch than the other patch types. In the case of the V notches, the distribution of the normal stress along the plate ligament are presented for different V notch angles. The stress concentration factor decreases by increasing the notch angle, which leads to a stress reduction. The reduction of the stress concentration factor values is more noticeable for the double patch than the simple patch reinforcement technique. So, as a conclusion, we can say that the use of a boron epoxy double patch with an optimized patch thickness can be one of the most efficient ways to increase the performance of the patch reinforcement.